Much like the method section, the results section is another section that you usually just kind of skim over. This is where they're just giving the results of their statistical test, the results of their study, but they're not actually interpreting the results yet. They interpret the results in the discussion section. And that's why, unless you're looking for something very specific in the results section, usually I just kind of breeze through this because they're going to talk about the most important results in the discussion section anyways. You can see that it's a lot of jargon. And again, don't get too bogged down with the details. For example, I don't remember what Wilks lambda value means. I could probably look it up, but I probably wouldn't bother while I was reading this. It doesn't matter if you don't know what a Tukey test is. It's okay. F ratio, totally forgot what that is. I remember it vaguely. But again, it's not something that I would really need to know in that level of detail to be able to understand the most important bits of this study. And so for the results section, you're not going to answer a lot of questions because, again, we're just kind of looking through this, skim reading it. Some things that you will need to remember is, again, going back to the whole idea of statistics, these ANOVA, these t-tests. You don't have to know exactly what that is, but a lot of it's just looking at how different they are. And one phrase that's going to come up a lot in the results section is something called a p-value. So it might say like p equals 0.136, for example. A p-value is just our confidence level. And so if we have a really low p-value, it means that we're very confident. You can think of a p-value like an error percentage, for example. If you have a p-value of like 0.05, that you can interpret that as kind of like 5% error, right? So they're very, very different. We're very confident, even though there's a tiny bit of overlap, that these two groups are actually different. And you can see that reflected in the p-value. So there's a very low chance that these are actually going to be due to circumstantial things, errors in your measurement, up to random chance, coincidence, things like that. Whereas if you have a really high p-value, that means we're not confident at all. So for example, in case 2, there's so much overlap here that even though the groups are a little bit different, that could be due to chance, that could be due to error. So it has a high p-value to reflect the fact that we're not very confident that these two groups are actually different. So the things that affect the p-value are how different the groups are, which is what we just talked about. Are the curves really, really different, or is there a lot of overlap? And the second thing is the sample size. If you have a really low sample size, like n equals 5, so there's 5 individuals, that doesn't instill a lot of confidence. You can imagine that if you went out into a classroom and randomly picked 5 students and measured them for height, for example, you might get like 2 males and 2 females. Or 2 males and like 3 females. That's not going to be a very good representation of the entire United States population is by sampling 5 people, right? So if you sampled 5,000 people, then we'd be like, yes, we're very confident that these two groups are actually different. And so the higher the sample size, the more confident we are in our results, which is the lower the p-value is. So hopefully that wasn't too confusing. Again, all you really need to remember is that p-values is how confident we are that the groups are different. The lower the p-value, the more confident we are. And that how different the groups are and how big the sample size is going to tell us how confident we are. And the last thing that I wanted to go over, which is pointed out in the results section, is something called pre-spawn mortality. So pre-spawn mortality is when an adult is migrating back to their spawning grounds, they're mature, their eggs are ready, they're ready to go, but they die before they lay their eggs. And this can happen for a variety of reasons. There is natural pre-spawn mortality, especially with steelhead kelts. You can imagine that, spawning is a very energetically difficult and demanding process. They might make it to the spawning grounds or make it partially up the river, but don't quite make it to the finish line because they ran out of energy. So when they're talking about pre-spawn mortality, that's what they're referring to.